5.2 Part B, we're going to look at using two-way tables to find probabilities. Okay, so first of all, we need to answer the question, what is the general addition rule? The general addition rule looks like this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B happening at the same time. So you have to, this is an OR probability, and the common variable that's counted twice when you consider totals. So we subtract them to avoid overlap. So what that's saying is like the total of A and the total of B, but then there's some that are A and B. We don't want to count them twice. So that's why we have to subtract the intersection. We call this an intersection of A and B. So there's some symbols you need to know. The U is for union, and we use the word OR often for that. I call it the A. The A is the intersection, and it also means and. So that's what's saying. A or B could be probably A and B, A or B. Now, is this on the formula sheet? Yes, it is. Well, what happens if the events are mutually exclusive? Well, it's the same thing. You use the same thing, but this probability back here where the A and B happen is really a 0. And so that little piece of the equation drops off, which is what we talked about previously in another video. Probability of A or B for mutually exclusive events is just the probability of A plus the probability of B. And that's why. Now, let's look at an example on how we're going to use two-way tables to answer some questions. So, who owns a home? What's the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. Overall, 340 were homeowners, 310 were high school graduates, and 221 are both homeowners and high school graduates. So this paragraph gives me all the information I need to create a two-way table. First thing I need to decide is which one is the explanatory variable and which one's the response. Which one do we think explains the other better? Getting a high school, or graduating high school, or owning a home? Well, I would think that the explanatory variable is getting the high school diploma. And the reason you do that is because those are the columns in your table, and then the response variable is the rows. In this case, the response variable is home ownership. So when I draw my table, it look like this. High school graduate, not high school graduate. Homeowner, not homeowner. And the purple numbers are the numbers they gave me in my table right here. Now, I know enough. I can use just basic addition and subtraction to fill in the blue numbers. So I know if the total was 340 homeowners and 220 of them were high school grads, that means 119 of them did not graduate from high school. And so on and so forth to complete the table. All right, so I've created my table, and that's going to help me in calculating my probabilities on the next slide. Okay, so looking at this, we're going to take that table from the previous slide, and I'm just going to let G represent high school grad and H represent homeowner for abbreviation purposes as we go along. So the question says, suppose we choose a member of the sample at random. Find the probability that the member is a high school graduate. All right, high school graduate is a column right here. Okay, so all I have to do is look at the totals. So probability of graduate is 310 out of my table total of 500, and it's 0.62. Part C is a high school graduate, and there's the intersection word, and owns a home. So I literally look for the intersection of the row and the column for that. Okay, intersection of row and column for high school graduate and owns a home. Well, that's 221 out of the total. So I write it in probability speak here, intersection, graduate, and homeowner. 221 out of 500, and that gives me 0.442. Part D is a high school graduate or owns a home. Using the table, the or high school graduate is 221. High school graduates that do not own a home, okay? So I have to consider both. So I have to include that 89 right there. So I'm really looking at these three right here. I have to add those three and divide by the table total to get 0.858. Now, if you use the formula, the addition rule, you could do just totals. You could say high school graduate was 310. Homeowner was 340. But then I need to subtract the overlap, the 221. If I don't subtract them, I'm going to come up with a number greater than 1, and I'll know I have it wrong. But I have to subtract the overlap. That's the 221 right there. And I notice I get the same answer, either way you work. Now, I will say this. When you're doing probability, you do not have to convert it to a decimal. Sometimes it just works out like that, but especially if you're working with the table, the two-way table, it's preferable to leave them as fractions, honestly, and not reduced fractions. Leave them in terms of the table. Okay, so let's look at another example about phone usage. According to the National Center for Health Statistics, in December 2012, 60% of U.S. households had a traditional landline telephone. 89% of households had cell phones. 51% had both. Suppose we randomly selected a household in December 2012. So make a two-way table that displays the sample space of this chance process. So I've created my two-way table. The purple is the numbers I knew they gave me in the question. Now, in this case, notice we have decimal values. And that's because they gave it to us as percentages in the question, so I convert them to decimals. And they should all add up to 1. Okay? Now, again, the purple is what was given. The blue is what I just used addition and subtraction to fill in the gaps for. Like if landline was 60% of them, that means that the no landline had to be 40%. Okay? So I filled in my gaps, and then I'm ready to go on to part B. Well, part B says to construct a Venn diagram to represent the outcomes of the process. So we have two circles, a cell phone circle and a landline circle. Okay? If it's outside the cell phone circle, that means no cell phone. If it's outside the landline circle, that means no landline. So here's what it looks like. Let me talk you through it. So I have my landline circle, my cell circle. When I construct it, you always want to start with the AND section, the intersection right here, and go to your table. Well, what percent had both? Well, that was 51%. That goes right here in the center, in the overlap. Then I can work my way back. So landline percentages was 60%. Here's the deal. I can't put 60% out here because I've already accounted for 51% in here. So 60 minus 51 gives me 9%. So I put my 9% out here. And then I double check myself that 9% and 51% add up to 60, which was given. Same process for cell phones. Cell phones, it said that 89% had both. Well, so 89% minus 51 gives me the 38%. So that my entire cell phone circle represents the 89%. Now, there is a percent that's not accounted for, because if you add these up, you get 98%. So there's still 2% out there that don't have a landline and they don't have a cell phone. All right, so you got to put that in the outside of the two circles, but in the sample space. So these are just notes of what I told you just now. So part C, now I can answer the questions. Find the probability that the household has at least one of the two types of phones. Well, that could mean they have a landline only, a cell phone only, or they have both. So then I can use my diagram to just add those up. 0.09, 0.51, 0.38. When I add them up, I get 98%. All right? Find the probability that a household has neither type of phone. So that would mean outside the circles. Well, if I've done my diagram correctly, I can just look at it. So I would just say probability of neither phone is 0.02. Part E, find the probability that a household has a cell phone only. So I look at my cell phone circle, and it's the only, so it's the part that does not overlap. So that would have to be 0.38. So in notation, it would look like this. Probability of landline complement, so not landline, and cell phone. All right, that would be 0.38.